Alright, so we learned about sequences. Now we're going to talk about series. So series are basically, we're talking about sums. That's the main thing that you're talking about in a series. So a series oftentimes is associated with the symbol sigma. So that's a sigma, which again means sum. So this symbol here is our sigma. It's saying the sum when x equals 0 all the way to 5, evaluated at this equation. So we need to find out x equals 0. So if x equals 0, we've got 2 times 0 minus 1, 3 times 0 plus 8, which gives us 2 minus 1, we get 1, times, let's see, 3 times 0 is 0, and 8. So we have 8 there. Oh, my apologies, that should be negative. And so we have negative 8 instead. Alright, now we've got x equal to 1. So we've got 2 times 1 minus 1. And 3 times 1 plus 8. So we got 2 minus 1, that's 1. 3 plus 8, we get 12. So we have 12. X equals 2. We've got 2 times 2 minus 1. 3 times 2 plus 8. 4 minus 1 is 3. 6 plus 8, 14. We got 3 times 14, 42. X equals 3. 2 times 3 minus 1. 3 times 3 plus 8. 6 minus 1 is 5. We have 17. Times 5, we get 85. And now we've got x equals 4. 2 times 4 minus 1. And 3 times 4 plus 8. Seven times 20, 140. X equals 5. We've got 2 times 5 minus 1. 3 times 5 plus 8. And that's 9. 23 equals 207. And now we got to add all of those together. So we have negative 8 plus 12 plus 42 plus 85 plus 140 plus 207. 478 is the sum of that series. However, as you probably realized on the bottom of this paper, it tells you how we do this. So in the new fancy calculator, all you have to do is hit math and then 0. And the summation comes up for you. We're going to start with x. We start at 0. We're going to arrow up. We're going to evaluate 5. And then we're going to put in 2x. So we have 2x. Oops. Minus 1. And it looks like I need an extra pair of parentheses in here. 2x minus 1 times 3x plus 8, and sum that series, 477. Apparently I miscalculated one thing. This should be 477 then. So we've got check with calculator, and we got 477. Now, if you have one of the old calculators, you have to do what we did yesterday. Second catalog, instead we're going to go to 4, so I can actually go through this with you. Second catalog, you're going to hit 4, and you're going to arrow down until you get to oh, sorry, I meant arrow up. So let's go back to 4. Arrow up, it has summation. So summation, you're going to press enter. Now for you, it's not going to come up like this. You're going to get something, and you're going to go ahead and hit second catalog again, and then you're going to do what you did yesterday, entering in the sequence, put the formula in there for x starting at the low, so you're going to start at 0 for this one, and then end at 5. Right? So your job is to go through and do example number 2, and then we'll talk about that one tomorrow. But for now, we need to keep moving on. So we've used a summation to figure it out. Now let's come up with a summation. So just like a sequence, we need to come up with what the series is. So we've got to look at this and see what's going on here. Well, we're starting at 9, then we've got 16, 25. Looks like I've got the perfect squares again. But, perfect squares, sorry. But it looks like we're starting at 3. So that's 3 squared, 4 squared, 5 squared, and so on. So I gotta think about, well, I know I need x squared, but I need to start at 3, so I need to start at x squared plus something. X plus, and I'm going to be adding, if I started at that, I gotta start at 2, because the first term needs to be 3. Alright, so let's try that. We've got first term would be 3 squared, so that's 1 plus that's 3 squared, 2 plus 3 plus, okay, so summation now. What do I start at? Well, I'm starting actually at x equals 1. And I'm ending here at, this is 1, that's 2, 3, 4, 5. And that's my summation. Now again, summation, since we're starting at different things, you could have written this as the sum of x equals 3 and going 3, that's 4, 5, 6, 7 of x squared. So again, going back to, yeah, there's more than one correct formula. This is a perfect example here. It just depends on where you start at. Alright, I'm going to skip example 4. I'm going to let you try this one. So you try writing a formula for that one. Again, there's different ways you can. And we're going to go ahead and talk about example 5. So I notice I have a negative, positive, negative, positive. So I know it's alternating. So that tells me I need a negative to some power. Since I start with negative, I can start with the power n. And now I realize I have the odds. So alternating, and I have odds. Well, odds is 2n minus 1, if we recall from yesterday. So I need to put those two things together. Let's see if we put them together, if we can get the answer. So if I start with 1 and put together alternating times 2n minus 1, well, a1 is going to be negative 1 to the first power, 2 times 1 minus 1. So that's negative 1 times 1, which is negative 1. Well, let's test a2. Negative 1 to the second power makes it positive. 2 times 2 minus 1, well, that's 4 minus, it gives me 3. And again, let's just check one more just to make sure. Negative 1 cubed, so I know that's negative. 2 times 3 minus 1, that gives me negative 5. So again, my pattern is checking out. So now I just need to write the summation. So sum when x equals 1, or n, I used n here. So n equals 1, and I'm starting at 1, so I have 1 term, 2, 3, 4, 5, 6. I'm going to 6. I'm using negative 1 to the nth times 2n minus 1. So that is my summation formula. Alright, so lastly we just need to talk about rewriting indexes. So you may be given a formula, and it's going to say rewrite it using a new index. So I started with I equal to 4, but I want to end up with j equals 1. So I need to figure out what the new formula for this equation is. Well, how do I get from I to j? Or basically, I need to find what j is. So how do I get here? So j equals, or I equals, sorry. I equals j, and we're taking away, we're going to add 3 to it to get back and forth here. Well, if I is j plus 3, then I'm going to replace I with j plus 3. So I have 1 over j plus 3. So 1 over I became 1 over j plus 3 using that. And if I is 8, equals j plus 3. We'll subtract 3. J is now 5. So then that's my ending point here. So again, now if I'm rewriting this index, I need to figure out I equals, well, if I is 0, to get to 5, I need to do k minus 5. So then if I is 12, it's k minus 5, well, I'm going to add 5. So k equals 17, so 17 is my top index. Well, if it's 2i minus 1, that becomes 2k minus 5 minus 1. So I've got 2k minus 10 minus 1, which is 2k minus 11. So 2k minus 11. Alright, and just like we've been doing all video, you go ahead and try this one. Think about, again, how do I get from I to m? So I equals m, and then think about the rest of that, how you would get there. The last thing I want to talk about before we close out the video is, now that we've learned sequences and series, some of the differences. So a sequence is just a list. So it's terms like 5, 10, 15, 20, 25, and so on. A series is a sum. So again, we talked about that a lot today. So that would be more of if we had 5 plus 10, plus 15, plus 20, plus 25, and so on. The sum of a series is just a single number. So in this case, if we were to sum that, that'd be 75. So single number. Alright, so we'll talk about that in class, and we'll discover a few more series as well.